Hey guys, we're starting 9.1, and this is the beginning of our last chapter, and we are into our chapter on trigonometry. Now, I believe just about everything in this chapter should be a review from geometry. Now, I realize geometry feels like forever ago, and so this may look kind of brand new, and that's okay. I'm going to teach it like it's brand new. But as we're going through, if you're like, oh yeah, that looks familiar, well, that's why. You've seen all this before in geometry. All right, so let's start off with this triangle. Now, not everything, but most when we're talking about trigonometry, we're using a right triangle. Okay, so you'll see here I drew a right triangle. I put that little symbol right there. We should know by now that that's a theta, but if not, that little Greek letter is a theta. You have one on your screen right now. If you look at my screen, the problem, and you'll see a little, looks like a circle with a line going through it. Okay, it's used pretty much just like an X, except it always refers to an angle. So when you use that theta, it's just like X, but you know it refers to an angle. Okay, so there's my theta. And then we label the sides of my triangle. Well, opposite the 90-degree angle, or the longest side, is always the hypotenuse. Okay, that's we're usually okay with. And then depending on where this theta is, that determines the other two sides. Okay. Now, if the theta is here where I placed it, the side that doesn't touch the angle, or the side opposite the theta, so we're going opposite the theta, is the opposite. Okay, the side opposite of theta we call the opposite, which we of course use just the first letter O. Hypotenuse we use just the first letter H. And then that only leaves one more side. So there's always two sides touching the angle. One side's going to be the hypotenuse. The other side we call the adjacent, or just the A. Okay, so that's where we get the stuff from. And how we attach that or connect that to trigonometry is right here. This is the abbreviation you probably remember from geometry, SOHCAHTOA. Okay, SOHCAHTOA, SOHCAHTOA. And what that it does is it helps us just remember the order. Which the S stands for sine. Well, sine of theta is O, opposite, divided by H, hypotenuse. C stands for cosine, and it's A over H, or adjacent over hypotenuse. Tangent is O over A, or opposite over adjacent. And then we get these three, and maybe you don't remember these from geometry. Sometimes you get these, sometimes you don't. And all they are is the reciprocal. So this CSC, that stands for cosecant. Cosecant is the reciprocal of sine. So whereas sine is O over H, cosecant is H over O. Secant's the reciprocal of cosine, so it's H over A. And then cotangent, COT, is the reciprocal of tangent. Okay, you're going to want to write those down. Okay, screenshot, find that online somewhere in an image. You need to know that for the rest of this lesson, really this chapter, to make sense. Okay, so let's look at our first two problems. And by the way, I did just realize that I did on this, so pull that back over here because I didn't have it on full screen. Sorry. So here's our triangle, if you were having trouble seeing that. And here's those equations, sine, cosine, tangent, okay? And then their reciprocals. Sine's reciprocal is cosecant, cosine's reciprocal is secant, tangent's reciprocal is cotangent. So again, those right there and our triangle, you really need to know. So if you want to screenshot that or whatever, do so. One important thing to note is I put the theta right here in this corner. I could have put it in this corner instead. The hypotenuse would stay the same, but if I put theta right here in this corner, adjacent and opposite would flip, okay? Because opposite has to be opposite the theta. All right, so now let's look at number one. All right, so number one, they only give me two sides. Well, that's because it's a right triangle, and they assume that I remember Pythagorean theorem, which is a squared plus b squared equals c squared. Okay, where c has to be a hypotenuse, a and b are the two legs. Well, let's label this. This right here is opposite the angle, so I'm going to call it O. This one is touching the angle, I'm going to call it A. And this is the longest side, I'm going to call it H. For this, I'm going to rewrite this as, instead of A plus B equals C, I'm going to say A squared plus O squared equals the hypotenuse squared. Okay? And then I can fill in what I'm missing. I'm missing H. I have A, which is 5 squared, plus 12 squared equals, I don't have H, so H squared. Pull out my calculator. All right, so I have 5 squared plus 12 squared. And that gives me 169. The square root of 169, 13. So my hypotenuse is 13. Okay. It asks me now to write down my functions. So it wants to know what is sine of theta, cosine of theta, tangent theta. That's the first three. Let's find those. Well, sine, just remember, so is opposite over hypotenuse. Opposite is 12. Hypotenuse is 13. Cosine, co, is a over h, adjacent over hypotenuse, 5 over 13. Tangent is opposite, or TOA, opposite over adjacent, or 12 over 5. And again, those were from right here, right? So, ca, TOA. And then over here, cosecant, secant, and cotangent are just the reciprocals of those. So the reciprocal of sine is cosecant theta. And if I just flip this, I get 13 over 12. The reciprocal of cosine is secant theta. If I flip that, I get 13 over 5. And then tangent is 12 over 5, so cotangent would be the reciprocal, or 5 over 12. All right, I'll do that same exact thing right here for number 2. So again, instead of writing a plus b plus c, I'm going to say adjacent squared plus opposite squared equals hypotenuse squared. Now here's the theta way down here. Because the theta is down here, this is now my opposite. This is my hypotenuse. That's my adjacent. Okay, so let's plug in what I know. I don't know my adjacent. I know that my opposite is 4. My hypotenuse is 8. Well, adjacent squared plus, well, 4 squared is 16. 64 minus 16. 64 minus 16 is 48. So a squared equals 48. All right. If I try to take the square root, I don't get a perfect number, and that's okay. I'm going to write it as 48. I will try to simplify it just a little bit, though. Let's see here. What multiplies to make 48? Well, 4 and 12. 12 breaks into 4 and 3. Well, there's a pair, so 48 can be written as 4 square root of 3. All right, perfect. So now we can go ahead and write our functions out. So our first one's sine. Sine of theta is the opposite over the hypotenuse. 4 over 8. Well, 4 over 8 I can simplify. 4 over 8 is the same thing as 1/2. What about cosine? Cosine is the adjacent. 4 square root of 3 over the hypotenuse. And then again, 4 over 8 simplifies to just 1 square root of 3 over 2. And then tangent theta. Tangent's opposite over adjacent, or 4 over 4 square root of 3. Now the 4's cancel out, and I'm left with 1 over the square root of 3. But remember, they don't like me to leave square roots on the bottom, so I'm going to multiply top and bottom by the square root of 3, which gives me square root of 3 times square root of 3 is 3. 1 times square root of 3 is square root of 3. Okay, so I just multiply by this, whatever that square root is on the bottom, so that now the square root's on the top. Okay, I don't really have room to put the reciprocals beside them, so I'm just going to keep going down. The reciprocal of sine is cosecant theta. Well, I had 1/2 here, so the reciprocal of 1/2 is just 2. The reciprocal of cosine is secant theta. I had square root of 3 over 2, so it's going to be 2 over square root of 3. But, oops, that leaves me with a square root at the bottom, so I need to multiply top and bottom by square root of 3. And that gives me, well, 2 square root of 3 over 3. And then the reciprocal of tangent is cotangent theta. Now I had 1 over square root of 3, which I had to change. But if I do the reciprocal of that, I get square root of 3 over 1, or just square root of 3, which is okay. All right, and then there we go. There's the first 2 problems. Let's see what else they want you to do. Okay, let's see here. Let's look at number 3. Okay, so they give me a problem. They say, number 3, sine of theta is 3 over 7, and cotangent theta is 2 square root of 10 over 3. Okay, and then they say draw the triangle. And so we'll put a little theta here, and then write the other equations. All right, go back to, all right, so this is what they give me. They say draw the triangle. I don't draw my triangles to scale. I just draw a basic right triangle, put a theta somewhere, and then label it. Okay, so let's start off with sine. Sine is opposite over hypotenuse. Well, I know that this over here is my opposite. This is my hypotenuse. This is my adjacent. So I can go over here. Sorry, before I move on. My cotangent. Well, tangent is opposite over adjacent. So this one is adjacent over opposite. Well, both of my opposites say 3. Right here, I know my hypotenuse is 7. And here it says my cotangent, or my adjacent, excuse me, is 2 square root of 10. So there we go. I have my triangle labeled. Only thing left to do is to write my other trig functions. So I have sine. I need cosine. Well, cosine of theta is adjacent over hypotenuse. So 2 square root of 10 over 7. The reciprocal of cosine is, secant. Well, if I flip that, I get 7 over 2 square root of 10. I need to multiply top and bottom by square root of 10. And that gives me 7 square root of 10 over, well, that gives me 10 times 2, which is 20. All right, let's see here. What else do I know? Here's cotangent. The reciprocal of cotangent is tangent. So tangent of theta has to be the reciprocal of this, or 3 over 2 square root of 10. Multiply top and bottom by square root of 10. 3 square root of 10 over 20. And then my only one I'm missing is cosecant, which is the reciprocal of sine. I know sine. Sine is 3 over 7. So cosecant has to be 7 over 3. And there we go. 1, 2, 3, 4, 5, 6 trig functions and our triangle. All right, moving down. It says, so for these, all right, we're doing pretty much the same thing we did on number 3. So I'm just going to do number 4 here. After I do number 4, the rest should be, as far as 5 and 6, it should be pretty obvious. So number 4 is sine theta equals 4 over 11. And then I'm going to go ahead and scroll down and look at the other ones we're missing. All right, so that I can have those ready for us. I'll give myself plenty of room for that one. Number 8, they give me a triangle and ask me to solve for x. Same thing for number 9, we'll do both of those. And then number 10, okay, let's see here. Well, hopefully you can see the screen well enough because I'm going to, actually here, I'll read it out. No, we'll draw a triangle. It says a parasailer is attached to a boat with a rope 80 feet long. The angle of elevation from the boat to the parasailer is 36 degrees. Estimate the parasailer's height above the boat. So we have our little person up here. He's got a parachute. Yep. We'll call that a parachute. We have our little boat down here. Everybody parasails from a sailboat, of course. So, yeah. There we go. It says my angle, hopefully you can see this on the video, is 36 degrees. The rope is 80 feet long. What is the parasailer's height above the boat? Okay. That right there. All right, so we'll solve that one in a second. So let's switch back to being video full screen. All right, we can go back up to number 4. So again, I'm just going to draw my triangle. I'll put a theta right there. It doesn't really matter where I put it as long as I put everything else in the correct spots. Sine is opposite over hypotenuse. Because I put theta there, there's opposite, there's adjacent, there's hypotenuse. So opposite or 4 goes right here, 11 goes right here. I need to find my a. So opposite squared plus adjacent squared equals hypotenuse squared, or a squared plus b squared equals c squared. My opposite is 4 squared, don't know adjacent, 11 squared. 16 plus a squared equals 121. Let's see here, what is 121 minus 16? It's 105. It definitely doesn't have a perfect square root. 105 divided by 5 is 21, which would be 3 and 7, so I can't even simplify that. So I'm just going to leave a as square root of 105. At this point in time, maybe you're wondering, wait a second, Mr. Cowan, you told me over and over again that when you take the square root, you have to put plus or minus in front, which is correct. Except that right here, remember, a is the length of our triangle, and I cannot have a negative length of a triangle. So that's why I didn't put plus or minus in front. I'm just using the positive because I can't have negative length. So there we go. All right. So there's a, it's square root of 105. All right. So let's write out our trig functions. Sine of theta. Oh, they gave me sine of theta already. Sorry, I don't need that one. Because they gave me sine, let's go ahead and do the easy one. Cosecant. All right, cosecant is just a reciprocal. So 11 over 4. All right. Let's try, so cosine theta. Cosine is adjacent over hypotenuse. So 105 over 11. The reciprocal of cosine is secant theta, 11 over square root of 105. So I need to multiply square root of 105 top and bottom and get 11 square root of 105 over 105. Let's see here, sine, cosine, tangent. Tangent is opposite over adjacent. So 4 over square root of 105. So multiply square root of 105 to both sides. And 4 square root of 105 over 105. And then cotangent theta. I'm just going to do reciprocal of that. 105 over 4. There we go. And I'll circle those because there's a lot of stuff there. There we go. There's our 1, 2, 3, 4, 5 different ones. Yep. Okay. Moving on. These are better. I like these. These are less tedious. All right. So we have this angle right here. Now, so far they've made me use all of the trig functions. Here I get to pick which trig function I want to use. And I want to pick it based on what I'm given. So here's my angle. This side over here is my opposite. This is my hypotenuse. Well, which trig function uses opposite and hypotenuse? Well, sine. Sine of theta is equal to the opposite over hypotenuse. And then I'm just going to plug in. Well, my angle is 30 degrees. My opposite is x. My hypotenuse is 10. And I can solve that for x. Well, how do I go about solving it for x? Now, on these problems, sometimes x is on top, sometimes x is on the bottom. It doesn't matter where it is. I'm always going to multiply both sides by the denominator. In this case, my denominator is 10. Now, if x is on the numerator, that means this is really the only step I have to do because I cross those out and then x is by itself. I can plug that in my calculator, okay? Now again, I don't know how well you can see my calculator screen. I know it's a little blurry, but I want to point this out. You need to hit the mode button on your calculator. See that mode button right there? If you're on your phone, if you're doing this on your phone calculator, it will work. You have a mode button on it as well, or at least you can switch between the two. Right here, it has radian and degree, okay? So my angle is in degree mode, so I need to switch it to degree. On your phone, it'll say like RAD or DEG, and most calculators default to radian or RAD. So because our angle's in degrees, we need to change it to degree. We'll learn about radians tomorrow. All right, so now it's in DEG, so now I can hit second quit, and now I can just plug this in my calculator. 10 sine 30, and I get 5. My x is 5, okay? Same thing over here. Here's an angle. Oh, they actually gave me the same trig function again. I don't know why they did that. Here's my angle. This is opposite hypotenuse. So I'm going to use sine again. They could have made me use cosine or tangent. It would have worked the same way. But yeah. So sine theta opposite over hypotenuse. Oops, it's 11, not 10. Sorry, let me try that again. Sine theta opposite over hypotenuse, and now I'll plug in. Sine of 60 equals x over 11. There we go. Multiply by the denominator, which is 11. Keep on right, 10. Cross those out, and then x is this. So on my calculator, 11 sine of 60, and I get, it told me to round to 2 decimal places, so x equals 9.53. All right. Well, let's now look at the one we drew. They gave me a little description of this person who's parasailing. Okay. Notice that after I drew it, it now looks just like the problems we just did. So I'm going to say sine theta, because it's opposite and hypotenuse again, equals opposite over hypotenuse. So my angle is 36, x over 80, multiply by the denominator, and then plug that in my calculator. 80 sine of 36. Round to 2 decimal places, 47.02 feet. And that is the end of 9.1.